All right, in this lesson, we're going to be talking about isotopes and ions. So the last lesson we talked about neutral atoms, and I told you that the way we figured out it was neutral was if there was no charge by the symbol. Well, now we're going to talk about what happens if there is a charge by those symbols. So by the end of this lesson, you should be able to describe the differences between isotopes and ions and their neutral atom element. All right, so isotopes. This is an atom that has the same element but a different number of neutrons. So it has the same number of protons, the same number of electrons, but the neutrons are different. So two isotopes of an element will have the same atomic number, but they'll have different masses. Because remember, the atomic mass, I'm going to symbol it as AM, is equal to the protons and the neutrons. Because remember, we calculated how many neutrons an atom had by taking the atomic mass and subtracting the atomic number, and the atomic number was the number of protons. So if we change the number of neutrons, we're going to change the mass of the atom. So I want you to take a look at this picture on the left here. What we haven't talked about is what these numbers here on the side mean. So this number here is the mass, and this number here is the atomic number. All you need to know right now. So the first thing we want to know is, what is the mass of the number of the carbon on top? Okay, easy peasy. I just told you that this one right here was the mass, so that means this is 12. Okay, what's the mass of the number of the carbon in the middle? Number on top is the mass, so that means this mass is 13. Okay, what's the mass of the number of the carbon on the bottom? Top is mass, so that means this one is 14. All right, well, that was fairly simple, I believe. Now, let's take a look at these atomic numbers. I told you that the atomic number was the number on the bottom. So what is the atomic number for each of these? Hint, they're all the same. So, like I was talking about, the isotope is the change in neutrons. So it's a change in this mass. As you notice that this mass is increasing, it's a change in the mass, but it doesn't change the atomic number. The atomic number never changes. It always stays the same. The only thing in an atom that can change are the electrons and the neutrons. Let me write that down so it kind of sticks in your brain. Only thing that changes. Changes in an atom is the electrons and the neutrons. All right. So in order to write the isotope notation, we're going to write the atomic symbol. So this C, that's the symbol for carbon. And then you're going to put the mass number on top and the atomic number on the bottom. So here I put those carbons there again just to show you each of those again. And this little symbol here, so this X is just a placeholder for any atomic symbol that we have. And then we put the mass number on top, atomic number on the bottom. And the mass number can be the one on the periodic table, or it can be one given to you that you've calculated because you know the number of neutrons are different than what the periodic table has. All right, so here's some examples. I want to know which of the following represents isotopes of the same element. So remember, if it's the same element, the atomic number is not going to change. So for number 1, the atomic number is 92. The atomic mass is 234. Okay? For number 2, the atomic mass is 234. Well, the atomic masses are the same, but the atomic number is 93. Okay? Let's take a look at the next one. So for number 3, the atomic mass is 235, and the atomic number is 92. All right, let's take a look at the 4th one here. The mass number here is 238, but the atomic number is 92. All right, so like I've said a couple times now, if it's the same element, the atomic number is not going to change because the protons can never change. And the protons are equal to the atomic number. So the protons never change. The mass number can change and go all willy-nilly and crazy. The atomic number never changes. So the ones with the same element are going to be all the 92s because the atomic number is on the bottom, and that means that it's the same element. So, quick question, I want to know what element this is, because this X does not appropriately indicate what element we're talking about. So if you take a look at your periodic table, find atomic number 92. It's on the very bottom. It's going to be uranium. The atomic symbol is U. And this is uranium. All right, so let's do some practice. So we've got some naturally occurring nitrogens here that have 3 different isotopes. We've got N14, N15, and N16. Just so you know, this is a shorthand way to write the different masses, the different isotopes for it, because we know that nitrogen has an atomic number of 7. So if we're writing the atomic symbol and we need to indicate if the mass is different, this is how we're going to write it. All right, so now we need to figure out how many protons, neutrons, and electrons are in each of these. Oops, I wrote carbons. I mean neutrons. Or nitrogens. Wow. All right, so the first one here, we've got 14 for a mass number, 7 for an atomic number. Well, we know 7 equals protons, so we're automatically just going to write that right there. Okay, there's no charge indication here, so that means it's a neutral atom, so then we know that there are 7 electrons. All right, and now we're going to take the mass number, subtracted the atomic number, and that's going to give us 7 for our number of neutrons. Let's do the next one. So, protons equal the atomic number, which is the same, no charge. So that means electrons equal protons, which is 7. And then now we need to figure out how many neutrons. Take 15 minus 7. So this gives you 8. Okay, do the last one. Protons, again, like I've said, they never change. So they equal the atomic number, which is 7. There is no charge, so that means electrons equal protons, which is 7 again. Now we got to take 16 minus 7 to get our number of neutrons. Well, that's 9. So as you can see, looking at all of these numbers, nothing has changed except for the number of neutrons. The number of protons and number of electrons have stayed the same, 7 all the way through. But the number of neutrons has increased by 1 each time.